Hey guys, what's up? It's your boy Trix. Today we're going to be doing a Rust video. Hang on, I just realized something. Give me one sec. Hey guys, I'm back. I'm so upset right now. My camera stand just broke from my phone. I literally had to bend the legs to prop it up, so now it's like doing a balancing act or something. It's terrible, man. Anyway, we're gonna be doing another Rust Rogue stream, just of me coding in Rust to try building this game. That's so annoying, man. Well, I'm getting paid now. I can buy a new one. Anyway, let's get into the video. So let me just cd into docs, cd into learning. Oh shit. Cd into programming, cd into Rust Rogue. Cool. Again, I've linked the tutorial in the description because it's a good tutorial. Anyway, so about entities and components. If you worked, hang on, I just want to get some music up. Let me just edit my settings on OBS so that you guys don't hear the music. Hang on one sec. I just need to properties, switch to built-in. There we go. Then let me just, I'll play a YouTube video so that Rust on brand. Let me just let me play this. Nice. I just want to have some music going in the background, and I don't want to have any copyright nonsense to deal with. Anyway, there. Because when I'm programming, I like to listen to hip hop, Korean hip hop actually. But yeah. Anyway, let's get into some Rust coding. If you worked on games before, you may well be used to an object-oriented design. This is very common even in original Python. There's nothing really wrong with an object-oriented programming design, but game developers have moved away from it, mostly because it can become quite confusing when you start to expand your game beyond your original design ideas. You've probably seen a class hierarchy such as the simplified one, based on the two monster, melee mob, orc warrior, orc archer mob, orc archer. Basically, this is saying you'll have a base entity, which is like a super class. Then these are all subclasses that extend this super class. So a monster is a base entity, and then you'll have a melee mob and an archer mob, which are direct descendants of monster. And then of a melee mob, you will have an orc warrior, because that's melee attack. That has a melee attack. But an orc archer is a descendant of an archer mob, because archers don't have melee attacks. you probably have something more complicated but it works as an illustration. Base entity would contain code data required to appear on the map as an entity. Monster indicates that it's a bad guy. Mini mob would hold the logic for finding these mini targets, closing in and killing them. Likewise, archer mob would try to maintain the optimal range and use their ranged weapon to fire and from a safe distance. The problem with a taxonomy like this is that it can be restrictive, and before you know it, you are starting to write separate classes for more complicated combinations. For example, what if we come up with an orc that can do both melee and archer, and may become friendly if you've completed the friends with the greenskins quest. You might well end up combining logic from all of them into one special case class. It works, and plenty of games have published doing just that, but what if there were an easier way? I need some water. I literally just ran out of water, fuck. If I need more water, I'll go grab some. Entity component based design tries to eliminate the hierarchy and instead implement a set of... I always forget to bring up chat, man. Fuck. Hang on. Where's chat? There's chat. I suck so bad, man. Let me switch this to a floating window. Can I switch this to tile? No. Maki? No. That's all right. That I can work with this. No, I can't. Flirting. I'll take flirting. Nah, why is the bounds on this so weird, man? Should I switch to... I don't know what's wrong with this. Let me switch to 3. Let me see what's wrong with this. No, you work fine, the hell? Nah, tile. Center work. Full screen. Okay. Let's try Maki now. The fuck? that's painful. Let me see, can I move it here? I can move you, so what the fuck's wrong with you? Floating. I like having that there. Let me put chat. Fuck, man. God damn it, chat. Pop out. God damn it. Docs. No? Come on. Let me disable chat. Let me enable chat again. Oh, god damn you, chat. Yeah, come on. Chat. God damn you, chat. Really? Ugh. I can't even. Oh. Fuck it, I'll fix it later. How does that look? That's fine, that redoes it. This, I'm just gonna chuck there. Fucking annoying, man. Fuck. Anyway, let me just close that, and then before you know, you're starting to write the using arrangements of the sentence. Where's the bit where? Yeah, okay, cool. Entity component-based design tries to eliminate the hierarchy and instead implement a set of components that describe what you want. An entity is a thing, anything, really. An orc, a wolf, a potion, an ethereal hard drive, formatting ghost, whatever you want. It's also really simple, a little more than an identification number. Magic comes from entities being able to have as many components as you want to add. Components are just data grouped by whatever properties you want to give it an entity for. So you could build the same set. Mini AI and the sort of game stats, and you can have everything you need to make it approach the player and try to hit them up. I'm taking a, what's this called? Tyrosets. They're anesthetic to numb throat pain. I have like a minor cold. They're all broken, so I just estimate how much one tab is. Press to play and try to hit them. Archer might be the same thing, but replacing mini AI and ranged AI hybrid could keep all the components, but every AI have both AI. You take the additional work up front to make life easier. So look at simple examples of, again, reading when you got words coming at you hard, man. But searching, you can find a bunch of different ways to approach ECS. There's plenty of object oriented approaches. There are plenty of free function approaches. They all have. Hang on. But now it sounds the same. I dropped this side in water the other day, and I'm worried that it might still be a bit funky, because I think a while ago this was sounding very muted compared to the left side, but I gave it a day just to simmer in some silica gel. That just dries it out, and it sounds okay now, but I am worried that maybe I might hear some type of audible imbalance, or tonal imbalance volume imbalance in both. But so far I can't hear anything. It might be very minute, but they still sound okay, and I don't see any corrosion. I think it's okay, because these weren't plugged in when they fell in water, so I think it's okay. But we'll see over the next coming days. If these do kick the bucket, I'll just upgrade. I don't want to upgrade that recently though. I want to upgrade in a couple months. I wholeheartedly agree with this this paragraph. Like, one of the senior devs on my team, he gave me this book to read, right? It's called The Philosophy of Software Design. There is one chapter that's only 3 pages long, because every other chapter is like about 10 pages, and that chapter literally says design it twice. Like, it goes over how when you're designing something, don't always just go for the first design that comes to your mind. And he's done this as well, where we've gone over like designing a piece of architecture for our code base, and we were just on call, and he went over like multiple designs of the same thing, and until I started reading this book, I didn't know why. And it basically says you could have that one idea in your head that, oh, you need to do it this way, and most smart people feel like their first idea, especially when it comes to programming, you feel like your first idea is the best idea, and you don't consider other ideas, because one, testing out those other ideas waste time in case your first idea was the correct way to do it. Two, considering other ideas, because you're considering another idea, it gives you less development time, and it makes you feel like you're not progressing as much in terms of like how much you've got done. And most of the time when someone tells me, oh, they don't like to design things, it's mainly because they don't want to waste that effort of they've gone out to design it and then getting told that it's not the right way to do it. But with that being said, doing alternate designs helps you understand the best way of doing it. So you could design something, and then until you try to think about an alternative solution or try and design it a different way, you won't know if that's the best way to do it. You may be able to refactor something in different ways to make it easier for you to add code to later on, and to improve the functionality of it if you were to design it multiple ways. And the saying goes, if your first idea is the right one, designing alternate ways to build it can help validate your choice in designing it. Because doing alternate designs, you can find issues with that design or your current design and improve on it. It's not just, oh, you need to design a completely new way to do it. You can change in small things and see if that improves the design or doesn't improve the design. But most of the time, it's helpful just to see how you would do it, and then finding flaws in it and going with the one with the least amount of flaws that makes things the most extensible and the most useful for you. Because at the end of the day, you're the one that's going to be programming it and using that code base. So making something extremely complicated, or using a shit ton of classes, functions, or whatever, and yeah, cool, you've added documentation, but now it's a pain in the ass to modify. There's no point. The whole point of coding for extensibility and for longevity is codes so that whatever you're doing makes it simple for you in the future. Yeah, that might put a lot of code, that might put a lot of pressure, or like put a lot of work on you up front to actually get that done, but it's a lot better doing that now than it is trying to do that later on and refactoring to death, trying to fix what you could have just started out doing in the first place. So yeah, I wholeheartedly agree with this. There's no right way to do it. If someone tells you, oh, you need to implement it like this, or you need to implement it like that, that's just because that might be the first thing that came to their head, or that's the first thing that they thought of. Unless you actually go out of your way to actually talk about, okay, what about if we do it like this? What about if we do it like that? Trying to come down to the best way to actually do it and implement it to make it easier to extend and improve on later on will do you a lot better. Even if their decision was the right one, going through that to help you understand why it's the right decision is a lot better when you're designing alternate ways to implement it. Although I'm talking to probably myself, if someone does watch this back, just take that into account. We want to tell cargo we're going to use specs. Open your cargo that someone change the dependencies. Okay, so cd into docs, learning, Rust, programming, and then this one's supposed to be Rust Rogue. Okay, get branch -b, and then this is going to be entities and components. Chapter 2.1 is 2.1, isn't it? Yeah, 2.1 / entities and components. Git checkout -b chapter -2.1 / entities and components. There we are. Okay, so there's this, and then cool. Cargo.toml. Okay, so inside dependencies, you want to tell Cargo that when you use spec and change dependency sections like this. Okay, so version equals 0.8.0 specs equals 0.16.1. Whoops, of course I fucking forget 0.16.1 specs slash drive, derive equals 0.4.1. By the way, I'm fucking up so bad because at work I use a MacBook and the at and the speech mark symbols are switched. That's annoying. This is pretty straightforward. We're telling us that we still want to use RLTK, and we're also asking for specs. The version number is current at time of writing. You can check for the new ones by typing cargo search specs. We're also adding specs drive, which provides okay, let me find out what let me undo. Let me just start out with version equals like that. Then I want specs equals, let me find the right version of specs. What is it? Cargo search specs 0.18. Fuck man, I keep doing that. And then cargo cargo search specs slash there we are. Zero point 4.1. Cool. Specs derive, which provides some helper code to reduce the amount of boilerplate and typing you have to do. At the top of main.rus, we add the following lines. TK. Okay, let me change this. Change 3 words. There we are. Game state. RLTK. RGB. Virtual keycode. Use specs. Prelude. And grab everything. Use std, let's compare, and you want to grab max and min. Oh, fuck. And now we want to use specs drive component. Use RLTK shorthand. You can type RLTK : console every time you want a console. This tells us that we'd like to type console instead. Likewise, use specs : prelude : all line is there so we aren't continually typing specs prelude world when we just want world. Yes, so this is kind of like import all in Python when you do import all from it's from import all, kind of like that, where you grab everything from a package to import everything. so you don't have to do random dot whatever. You just use the actual method that you want to call. Line is there, so you aren't continually typing specs. Yep. Oh, quite a scary looking macro use call. You don't need that anymore. You can just directly use the macro. We need a derivation from specs derived components. We add use specs component. There we are. I'm going to build a little demo that uses ECS to put characters on the screen and move them around. A basic part of this is to find the position so that entities know where they are. We'll keep it simple. Positions are just X and Y coordinates on the screen. So we define a strat. These are like structs in C, records in Pascal. It's for a group of data stored together. Structs and structures. Okay, so if I do struct, I just need to grab that and then change that to position. And then insert fudge, change word X, and then Y colon 32. This is just saying that you want a signed 32-bit integer. Fuck. Close the accident. I meant to write W instead of WQ. Shit. Anyway. Very simple. Position component has X and Y coordinates as 32-bit integers. Our position structure is what is known as a pod, short for plain old data. It is just data. It doesn't have any logic of its own. This is a common theme with pure ECS entity component system. They are just data with no associated logic. The logic will be implemented elsewhere. There are two reasons to use this model. It keeps all your code that does something in systems. That is code that runs across components and entities and performance. It's very fast to keep all the positions next to each other in memory with no redirects. At this point you could use position S, but there's very little to help you store them or assign them to anyone, so we need to tell specs that it is component. Specs provide a lot of options for this, but we want to keep it simple. The long form no specs drive help would look like this. Implement for position. Okay, so you'll probably have a lot of components by the time your game is done, so that's a lot of typing. Yeah, because you'll need to implement a component for that position, and so you want storage. You want a type of storage for that position to have a vector storage object, which just takes a position. Which just takes a component, I'm guessing. You'll probably have a lot of components by the time. So, oh no, you'll take a position. So that's a lot of typing on that, but it's not typing the same. But it's lots of typing the same thing over and over with the potential to get confusing. Unfortunately, specs derive. But there's an easier way. You can replace the previous code with this. So hashtag derive component with this hashtag derive X is a macro that says, from my basic data, please derive boilerplate needed for X. In this case, X is a component. The macro generates the additional code for you, so you don't have to type it in for every component. It makes it nice and easy to use. The macro use specific from earlier is making use of this derived macros. But then it's additional functionality for a structure on your behalf, saving lots of typing. Defining a renderable component, a second part. Put in character on the screen is what character should we draw and in what color. To handle this, we'll create a second component renderable. It will contain a foreground, background, and glyphs such as the renders, or create a second component structure. Okay, so let me do this. Derive component. And we want to struct with renderable glyph and RLTK font char type. Then we want FG for foreground, which is just RGB, and then BG, which is background for RGB. RGB comes from RLTK and represents a color. That's why we had to use RLTK RGB. Statement otherwise we'd be typing RLTK RGB every time they're saving keystrokes. Once again, this is a plain old data structure, and we are using derive macro to add component storage information without having to type it all out. Words with restrictions, so now we have two components. Let me just check something. Yeah, it should be alright. Let me just check something. Yeah, it's alright. I was worried that my mic was somehow picking up my music, but then I was like, I've got my IEMs in, there's no way. Anyway, why is code not showing? That's so annoying, man. Oh, fuck's sake. The stream's always scuffed, you guys know that already. So now I need two component types, but that's only very useful without something somewhere to put them. Specs requires that you register your components to start up. What do you register the world? A world is an ECS provided by the REST create specs. You can have more than one if you want, but we won't go there. You want external state structure to have a place to store the world. Okay, so inside here we'll have ECS colon world. Now in the main we create the world, we'll put the ECS in. Okay. So we're saying that we want the state to be mutable. Then we're saying ECS is just a new world. Another constructor is a method inside the world type, but without a reference to self, so it doesn't work on existing world objects. You can only make new ones. This is a pattern used everywhere in Rust, so it's a good idea to be familiar with it. The next thing to do is tell ECS about the components we created. We do this right after creating the world. So this would be gs.ecs.register register position, gs.ecs.register register colon, and then we want a renderable. I just want to position. There we go. I can't spell, guys. What does it tell our world? What this does is tell our world to take a look at the types we are giving it and do some internal magic to create storage systems for each of them. Specs has made this easy so long as it implements component. You can put things like in this component creating entities. Now we've got a world that knows how to store positions and renderable components. Having these components simply exist doesn't help us. Beyond providing an indication of structure, in order to use them, they need to be attached to something in the game. In the ECS world, that something is called an entity. Entities are quite simple. They are little more than an identification number telling the ECS that an entity exists. They can have any combination of components attached to them. In this case, we're going to make an entity that knows where it is on the screen. And knows how it should be represented on the screen. We can create in the two both renderable position components like this. gs.ecs.create underscore entity, then dot with position of x colon 40, y colon 25, dot with a renderable of glyph RLTK 2 underscore CP 437, the @ symbol, then foreground color we want RGB colon named RLTK. We want yellow. And then background color. You know what? Instead of my foreground being yellow, I want my foreground to be red. And I want my background to be purple. Okay. It tells our world, ECS in GS, our game state, that we like a new entity. That entity should have a position. You know what I like? Purple. Purple. And black. Should have a position. We pick the middle of the console, and we like to do a renderable with an @ symbol in the yellow and black. That's very simple. We aren't even storing the entity. We could if we wanted to. We're just telling the world that it's there. Notice that we are using, interestingly, lots of functions that don't end in a semicolon to separate out the end of the statement, but instead lots of dots. Calls to another function. This is called the builder pattern and is very common in Rust. Combining functions in the fashion is called method chaining. A method is a function inside a structure. It turns a copy of itself, so each function runs in turn, passing itself as a folder for the next method in the chain. So in this example, we start with a create entity call, which creates a new empty entity on the entity we call with, which attaches a component to it. That in turn returns the partially built entity, so we can call with again to add the renderable component. Finally, the .build takes the assembled entity and does the hard part, actually putting together all of the disparate parts into the right parts for the ECS. You could easily add a bunch more entities if you want. Let's do just that. So just start this in a for loop then. For I in 0 to 10, then on the end here. There we are. Create, and then let's change this. I times 7, 20. That's a smiley face. No, fuck it, I'll just do an and. Purple, black, build. You know what, I'm just going to do the separation here. Call the for loop in the tutorial. If you use other programming languages, the concept will be familiar. Run the for loop with I set to every value from 0 to 9. With 9, you say Rust ranges are exclusive. They don't include the very last number in the range. This is for familiarity with languages like C, which normally write for I equals 0, I less than 10, I plus plus. If you actually want to go all the way to the end of the range, so 0 to, and you would write the rather cryptid for I in 0 ... equals 10. That looks like Buki JavaScript language right there. That I put in them in different positions every 7 characters 10 times, and we've changed the at to smiley faced. With one for the same thing. I'll do that then. I'll just change this to a 1. Why am I going to use this long thing for? Because I can't actually copy the smiley for some reason. Iterating entities. So now we have 11 entities with differing render characteristics and positions. It would be a great idea to do something with that data in our tick function. Yeah. We replace the call to hello Rust with the following. Okay. Positions self.ecs.read_storage position So let me try to guess what this does. So this sets that at this position and at this X and Y position on the screen, with this foreground and background color, place this glyph. Ask the ECS for read access to the container it is using to store. Shit. Of course, I forget. Position components. Likewise, we ask for read access to render to the renderable storage. It only makes sense to draw a character if it both these. You need a position to know where to draw, a renderable to know what to draw. You can learn more about the stores in the spec. The important part, read storage, you're asking for read-only access for the structure used to store mode. Foreseen spec has our back. Join positions and renderables like a database join. It only returns entities that have both. It then uses Rust destructuring to place each result, one result per entity that has both components. So for each iteration of the for loop, you get both components belonging to the same entity. That's enough to draw it. The join function returns an iterator. In C++, iterators provide a begin, next, and end function, and you can move between elements and collections with them. Rust extends the same concept only to steroids. Just about anything can be made into an iterator if you put your mind to it. Iterators work well with for loops. You can provide an iterator as a target in 4x in iterator loops. The we discussed earlier already is a range and offers an iterator for Rust native navigate. The other interesting thing here are parentheses in Rust. When you wrap variables in brackets, you are making a tuple. These are just collection of variables grouped together, but without needing to go and make a structure list of the case. Numeric access, -0, -1 to get each field, or you can destructure them. Set the variables 1 to 1, then the variable 2 to 2. That's what we're doing here. The join iterator is returning tuples containing position and the renderable component as .0 and .1. Since typing that is ugly and unclear, we destructure them into the named variables pos and render. This can be confusing at first, so if you're struggling, I recommend Rust by example section tuples. For every entity that had both a position and a renderable component, the drawing method is passing us both guaranteed to belong to the same entity. Any entities that have another, but not both, simply won't be included in the data returned to us. ATX is an instance of RLTK passed to us when TIC runs the office. Glyph colors of your choice, so we pass the data from pause, position, component for the entity, and the colors glyph from renderable. Place any entity that has both a position and a renderable will be rendered to the screen. You could add as many as you like, and they will render remove one component or the other, and won't be rendered as position component. Okay, I want to change this glyph, right? Because there's no point doing something if you don't make it interesting. So instead of smileys, I will do aces. Aces are 5. Cool. If you type all of that correctly, your main RS should literally this. Use RLTK, game state, RLTK, and GB. Why is virtual key code up here? Ah, it might be used for something in the future. Cool. Prelude, max min, component, derive, component position I32, derive, renderable, font chart type, RGB, state, ECS, game state, FNTIC, not, and then that one, and then that, and then I just added the spaces for readability. And then B error, use RLTK. Net context. I'm going to change this to Rust Rogue. Build ECS, register position. I'm going to add a breakpoint here. Not a breakpoint. What the fuck's wrong with me? I want to add things for readability. Spaces, I mean. That's alright, and then at the very end. I'm just going to build to check that I haven't fucked anything up. How do you update packages again? Let me see what this does, because I remember there being a command that I've forgotten. Where are you? I wonder why you're not running. Hang on. Let's see if it wants to update. Is grab specs derive? Is grab specs. Okay, it'll build now. Was it just that it didn't save properly? Let me go into cargo run because it should still run even if I'm not using it. No? Okay. Let me just... Where are you? Nice, I got it now. Sick. This example showed you how an ECS can disparate bag of entities to render. Go ahead and play around with entity creation. You can do a lot with this. Unfortunately, pretty boring. Nothing moving this rectify this bit and moving a shooting gallery type look. First, we'll create a new component called left mover. Entities that have this component are indicating that they are really I like to go to the left. Composition is very simple. Okay, so struct, let's change that to left mover, and it should be a component. Cool. Now we have to tell the ECS to use the type with our new register called we add. Left mover. Oh wait, I wanted to check. Can you guys still hear me? That's crazy. I'm whispering. That's mad. Nice. Anyway, it should sound the exact same no matter if I'm whispering or whatever. It might sound a bit quieter though, but cool. My audio should be working properly now. That's sick. Now to actually make the move, we're going to define our first system. Systems are a way to contain entity components logic together and have them run independently. There's lots of complex flexibility available, but we're going to keep it simple. Here's everything required for our left walker system. Okay, so struct left walker impl a system a for left walker, then type system data, read storage a left mover, then right storage a position, then fn run and mut self lefty mut pause self system data for lefty pause in and lefty and mut pause dot join pause dot x minus equals 1 if pause dot x greater than 0 pause dot x. Cool. This isn't as nice / simple as I'd like, but it does make sense when you understand it. Let's go through it piece by piece time. Left walker defines an empty struct somewhere to attach the logic. Means we are implementing spec system trait for our left walker struct. The apostrophe a or lifetime specifies the system is saying that the components that it uses must exist long enough for the system to run. For now, it's not worth worrying too much about it. Type system data is defining a type to tell specs where the system requires. In this case, read access to left mover components and write access since it updates to them to become position components. You can mix and match whatever you need in here. As we'll see in later chapters, fn run is the actual trait implementation required by the implement system. It takes itself and the system data we define. The for loop in the system shorthand for the same iteration we did in the rendering system. It will run once for each entity that has put the left mover in position. Note that we're putting an underscore before the left mover variable name. We never actually use it. We are requiring that the entity has what the underscore tells us. We know we aren't using it. This isn't a bug and stops it from warning us every time we compile. The meat of the loop is very simple. We subtract 1 from the position of the component, and if it is less than 0, we scoop back to the right of the screen. This is very simple to how we put the rendering code, but instead of calling into the ECS system is calling into us function system. It can be a tough judgment call on which to use. If our system just needs data from the ECS, then the system is the right place to put it. If it also needs access to our other systems of our program, probably better to implement it on the outside. Calling it now while we run our system, we need to be able to use it or add a run systems function to our state. Where is implement state? I'm not sure where this goes. Impl state. Ah, I know what to do. Impl state fn run underscore systems and mut self where mut lw left walker lw.run now and self.ecs ecs.maintain. There we are. Straightforward. Implement state means we would like to implement functionality for the state. FM runs systems and not self means we are defining a function and it needs mutable. It is allowed to change things. Access to self. This means it can access the data in its instance of state with the self keyword. Let LW left worker makes a new changeable instance of the left worker system. LW run now tells the system to run and tells it how to find the ECS self. ECS maintain tells specs that if anything changes were queued up by the system, they should apply to the finally we actually want to run in the tick function. We add this. Systems. The nice thing is that this will run all systems we register into our dispatcher, so as we add more we don't have to worry about calling them or even calling them in the right order. You still sometimes need more access to the dispatcher as our renderer isn't a system because it needs the context from LTK. So implement state, the right left mover. Left walker. I just put them in different places. You know what? Why am I doing it like this? I'm in fucking Vim. Let me just check why this is broken. Okay, that's fine. That's fine. Okay. Ah, I put it in the wrong place. Nice. That's so cool, man. I just figured something out. I'm using the wrong character. That's a 5. I want to change this. That's a 5. That's fine. I'm going to change enemies to diamonds for 4. And then I'm using the wrong character here. This should be a 6. Nice. Finally, let's make the player move. So now we'll make a new tag component. Okay. We'll register it. Add it to the player entity. Implement a new function called try and move player. FN try move player. Oh shit. Where's comment? Total comment. There we are. Try. Move. There we are. I have my water bottle in front of me, that's why I can barely see anything. Hang on, let me just scroll a bit there. Where am I? We haven't seen before. The context is providing information about a key, but the user may or may not be pressing one. Rust provides a feature for this. Option types have two possible values, none or some. The context provides a key variable is a enumeration that is a variable like a holder value from a set of predefined values. Keys on the keyboard. Rest enumeration are really powerful and can actually hold values as well, but we won't use that yet. So to get data out of an option, we need to unwrap it. There's a function called unwrap, but if you call it when there isn't any data, your program will crash. So we'll use Rust match command to peek inside. Matching is one of Rust's strongest benefits and highly recommended. So we will call match ctx.key. Yeah. And Rust expects us to provide a list of possible matches. In this case, ctx.key has only two possible matches, some are none. Line says match the case in which ctx.key has no data and runs an empty block. Some key is the option. There is some data and we'll ask for us to give it to us as a variable named key. Again, this time on the key, we have a line for each eventually we want to handle. Equals is another enumeration. We shall call that true. Try and move player function. We repeat that for all directions. Odd means anything else or anything. Okay. Don't take, if you don't specify every possible enumeration, it will give a compiler error, but including the default, we don't have to type every possible keystroke. Current game state and context, let's set the key variable in the context and calls it appropriate move command and the moving key unless we add in the tick. Player input self. Player input underscore input self ctx. Do I just add that here? Let me see. Yeah, virtual key code, that's fine, The right position, renderable, left mover, player, then state. Now let me move these, try move, and player input up there. Okay. Ah, shit. Let me grab this. There. And then if we do cargo build, there should be no compiler errors. Nice, cargo run. There we are, and now oh, but this is so cool. Nice. Oh wait, I can run this in the browser now. That's the one that the book has. I want to see if I can run what I currently have in the browser. Hang on. So building for the browser. Yeah. Yeah. Hang on, let me see the dev's GitHub. I want to see where he has his lesson folder. SLC. No. SLC. Okay. If this works, this is going to be sick. And then I can delete my WASM folder at the root of this project. because my... Which one failed? It's... Wasm Banjan is not working. Hang on. Wasm Banjan CI. Not working. Wasm dash Banjan dash CI. Let me just let that do that thing. I have no freaking idea why that keeps happening. Well, let me just... There we are. Then if I do... That's fine. That's fine, that's fine. And then this one. This is the one that I need to do. No. Is this one? Does he have his cargo at the top? Let me have a look at his cargo at the top. Is it because... No, there's no way it'll be because of the version of RLTK I'm using. I have no idea. I'm gonna update this to Rust Rogue though. Authors. That's upsetting that I couldn't get it running in the browser though. At least I know now where Wasm and Target should go. So let me just get add. Hang on. There we go. Components, so yeah. And if I go to my Rust Rogue, fuck's sake, hang on. Face cam is now gone, sorry guys. Cool beans. Now I won't be able to push to master unless I physically have access to master. Unless I physically remove that option, I mean. Oh, that's annoying. There we go. There we go. Love how no one can see anything. Anyway, thanks for watching. If you liked the video, please leave a like on the video. If you disliked the video, please leave a dislike on the video and comment down below ways I can improve content on the channel. Other than that, thanks for watching. Subscribe to the channel, like and subscribe. Enjoy the rest of the day and peace.